Hello, hello everyone. Hello, people of the internet. Time for some more bindings generator stuff. So let me check quickly. I remember I think it was here that yeah. Okay, so our goal for today is the following. We want to be able to generate this. Basically, the diff you see here, this was done manually by John. And we want to change the bindings generator so this kind of stuff gets generated automatically. So instead of generating unions, we in the future want to generate structs with overlays, which is simple, except for the fact that currently overlays cannot be bigger than the member you overlay. So we have to sort things in the union so that the biggest member comes first. And this is where things might get annoying. We'll figure it out. Hey, Valigo. Hey, Okros. Let's go. So we have on struct, we have a flag, whether it's a union. Yep. And we want to do this as early as possible so that that any visitor has a chance of modifying it if we do something wrong. So I think we will do it right in here when we do the children, blah, blah, blah. Blah, blah. For every child we create a declaration. If there is one, yeah, that's all good. We could do it in one pass. Let me see what finish bit field does. I can't remember. And also, why so small? I think this just, yeah, let's make sure that the alignment is right. It doesn't mess with the declarations. It doesn't mess with the size, maybe? Yeah, it messes with the size. Where the heck do we use the type? What? What magic is this? Oh, this is using, yeah, I'm becoming less and less of a fan of using. It's always, so here I didn't see, okay, where do we assign the type? Yeah, this is bitfield.type, but you can't see it because of the using. It's convenient, but it's like it makes it harder to understand the code. So unless it's something is a simple member function, I have stopped using. Okay, but this does set the type on the bit field, so we have to do it after this one, which is a shame because it means we need another. No, we can do this in one pass. Okay, we can say let's say largest declaration. And then after finish bit field, we say if struct flags is union, if its size, if not largest declaration, or its size bigger than large declaration size, declaration is it. And yeah, that should be it. Okay. And then down here we can say if largest declaration and struct declaration 0 is not largest declaration, then we'll have to swap those. Which means we want the index. Okay, how much of a mess do we want to make here? It would be... It's easiest to just swap the first and the largest declaration. But then the order of the bit field becomes weird. So maybe instead we want to move it to the top and shift all others down. Performance-wise, it doesn't really matter, and it makes it more understandable what's happening. Oh, and we have to... If any of the members has a... Okay, let's do this. If it's size less than 0, log it location, So this can happen, and this is one of the things we want to see with this experiment, whether it's like how often it happens that we have a union with members of unknown sizes. Cannot determine the largest member of blah. Overlay might be incorrect. Needs to be adjusted. Via the visitor and need adjustment. Okay, and this is is it flags? I can never... I think it's flags, or is it user flags or something? Something's weird about the log. Let's see. It's flags. Okay, good. And we'll only do that... Like, we'll guard this with an option afterwards so we don't spam people who know this. Ooh, I didn't finish the description. That's weird. I could have sworn that I entered something proper. Oh, ha 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 ha! The hash gets eaten. That's great. How does it look in the web view? Is this a problem of Chatterino or a problem of Twitch? Let me see. Nope, it's a problem of Twitch. Okay. Sorry, I didn't know you can't. Oh no, neither. I know what it is. Sorry, Twitch. That's my fault. This is our common symbol in the config, in the commands. I'm almost certain. Do we have an escape for that? I can't remember. Not important. Whatever. Let's just do this. Okay. So we want to move everyone down. What's the fastest way to do that? For one dot dot struct declarations count. Nope. If we want to move everyone down, we wanna know the index. So from 1 to id index, we're gonna say struct declarations. Let's say I here, and this is wrong, of course, lar. We want to move everyone down, but starting with 0 actually, or we do it with -1. I don't know. I'm never sure how to do these. Let's do it with +1. Wrong here. And this is of course the wrong direction. So we go backwards. I can't remember, this has been changed a couple of times. Does 4 now, 4 backwards with positive indices? Let's test this. Four backwards, 0 till 5, log id index, it. I think this works, but I'm not certain, so let's see. Oh. Wait, don't we have id index here? What? This can't be right. Whatever. 5, 4, 3, 2, 1, 0. Okay, perfect. That works. Just wanted to be sure. So this works. We go from wherever we found it, -1, and we move downwards. So that should do the right thing, unless I'm retarded. And it moves 0 to 1, and then we can say struct declarations. Fingers. Come on, you can do this. Is largest declaration. And we have something that's called prepend comment. Yeah, we're gonna do that. Prepend comment, largest declaration comment. Move to the start of the largest member, move to the start of the struct union to support overlay. Something like that. Okay, we should be able to see that already if it happens somewhere. So with this, we can say AGIR generate all. Nope. XGIR generate all. You know what? Let's, before we generate everything, we have a test suite for the bindings generator. we should add this, I think. So do we have any unions in here? Yes, plenty. Do we have any that would qualify for this? Oh yeah, perfect. So this is too big. Oh, it's a bit field. Oh, that's a nasty one. But still, this will be way bigger. So this should be pulled forward. You two should be pulled forward and get that comment in the test. So we can just say AJ minus R modules bindings generator tests first.jai. Let's go. What? Did this just choke on our 4? Oh, because it's like that, right? Size not a member of declaration. Yeah, because it's on the type. If not it dot type or its type. Size too small. Means we have interacting. Yeah, this one's a pointer, obviously. Boy, I'm bad. Incorrect number of arguments applied. What? Impossible. Oh yeah, I didn't supply any arguments. So we want it dot output name, and we want struct dot output name. Oops, that's not what I wanted. Okay, that worked. Let's look at the diff. No diff. Now I'm sad. Why don't we have any diff? I clearly saw that this is a union. It has 2 struct members. And this one should be bigger than this one, right? It's anonymous union. It makes it a bit annoying to track. So maybe we... What do we have here? This is bigger. Yeah, it's fine. Do we have something non-anonymous where the bigger one is last? Or do we have to create that test case? So many union test cases, but none of them fit properly. Okay, let's just create a union. Whatever. Does not matter. Let's put it above the regression tests. Let's put it above the vtable craziness. Above the packed craziness. I don't know. Where does it fit? Let's put it before the bit fields. Bit fields are crazy. Okay. We'll have union needs reordering, and this will be we have a uint 8t a and a uint 32t. Uint, boys, I can't type to save my life. And we'll have a struct complicated. Let's make it anonymous. And this will have 2 int members, so it should be smaller. And so we expect this one to be pulled forward. Let's do more. No, let's do more. And let's have a unit 8 to close the thing off. Make sense? Let's see what this does. It complains. Duplicate member A. Oh yeah. This is SA and this is SB. And this is complicated, not complicated. Getting there. Getting there. Okay, what does this look like? So we have needs reordering, C got pulled forwards, largest member moved to start of struct unit support overlay, and then the others. And we have a gap where we removed it because the locations forced that gap. Seems reasonable. Okay, that worked. So this is step 1. Step 2. Oh, objective C. Yeah, I'm not gonna touch objective C, I'm afraid. Not yet. Okay, so this one vanishes. Both are gonna be structs. Then we print all members. We have overlays. So we should move all the other struct members into overlays. So we go to is union. So we're going to do this again because now we need to do more. If it's a union, we first reorder and then we say for how does overlays constructed? Okay. So we're going to say for 1 dot dot struct the count -1 array add struct overlays place is if we don't have a largest declaration. Doesn't matter. We'll do this. Yeah, the loop is not going to fire if we only have one member, so we can just do this. So we'll place it at the declaration 0, and the declaration is struct declarations I. For some reason, I like to still use I for numbered loops. Okay, and then we say ooh, no, I'm doing something. Okay, this is not all declarations inside a struct are fields. Let's extend our test. If we do this, not a field, This must not be pulled forward. And we're gonna pull it forward. See, we're naughty. Oops. Naughty, naughty, naughty. Because we don't check whether things are fields. Let's do this, by the way. And then we'll say if what's it called? We'll see. I think it's called isField. Maybe it's struct field. Yep. So that should fix that. Oh no. Wait, why does this one have an offset? Shouldn't they all have offset 0? In a union? Wait a second. Okay, let's see. What are we doing? This all seems reasonable. Except, of course, nope. Okay, let's undo the change I did down here. We're not ready for this yet. Oh yeah, okay. This was just my mistake. Good. We say needs reordering. We have A, B, complicated, C, not a field D. And here it looks like C gets pulled, A, B, complicated, not a field D are unaffected so far. So far, so good. It makes sense to switch to start dates. Yeah. Probably. Okay, so over here. This is still fine. We want to move all declarations. Yeah, we don't want to keep the other. Yeah, we want to move all declarations. But here we want to say, this is annoying. I thought I can just at the end, what I wanted to do was just say struct declarations count is 1 and be done. So we move everything to overlays and then we just reset the count of the declarations to just have that one declaration. That's of course nonsense if some of them are not fields. So, and that also means this is wrong. So we'll call this not largest declaration. Largest field. That makes everything more obvious. And if we have largest field and wait, we shouldn't, let's make our test more complicated. There's more here. We want to do this, not a field 1. This is a small one, so we don't break our test from before. So not a field 1 and not a field 2. And we don't want to pull C up here. We just want to move C here. We want to do the minimum amount of transformations to the code. So we're going to say first field index. We can also keep first field around, but it doesn't really matter. No, first field index is important. If not, first field index, and that's not quite right. So we're gonna say first field index is -1. If first field index less than 0, first field index is it. Index. Boom. And then here we'll say if the first field index is not the largest field. And now, of course, we can say simply if first field index is not largest field index, then we have to start shuffling. And then we say for first field index, the largest field index, we'll shift them. And then this one is first field index. And now we do nice stuff. Okay. And now here. I want to do this as simply as simple as possible, and the fact that we might have things of unknown size makes things a bit annoying. Because I just want to create the overlays. No, it doesn't make sense, because this only happens if we move. So over here we would say we can do it from first field index +1 till the end. Say if is struct field if it is struct field, we create an overlay. The place is first field index, and the declaration is it. And now we need to remove it from the declarations, which feels messy, but I don't think there's a way. We could create a new declarations array in parallel, but is that better? Did I say no checking? No, this is no check-in. Oh, there's a missing. Yeah, sorry. Thank you. Okay. So this creates the overlays. I need to remove the members from the struct. It feels stupid to remove them one by one, going from the front to the back. We could go back to front, but then the overlays are in the wrong order. We could, if we insert the there's no winning this. Whatever. Array remove, unordered remove, nope. Ordered remove by index is probably faster. This is super slow, of course, but unless someone declares a union with thousands of members, we don't care. And this is the simplest code. And we blew up. Bounce check failed. What? Oh, if we don't have any fields, I guess. This is not good. If first field index greater equal to 0, Do we have any unions? We should have an empty. Is there something like an empty union in C? Probably. Index is 5, limit is 5. What? If I say till count -1, how can this be an out of, am I stupid? If I say I want to go till count -1, how can I go out of bounds at the count? Idea, keep order, but pad all unions the largest. No, you might have misunderstood what we're doing. I don't understand this. What am I not seeing? Oh, duh. I remove. Never mind. Stupid mistake. We remove by index. But then this should terminate. Or is it not evaluated? Is this not re-evaluated? Is the upper bound not re-evaluated? I did not know that. Oh yeah, he says maybe your move whilst inside the loop, yeah. Oh, and also, guys, I'm stupid. We have this. But this is unordered. This is unordered. Of course. If I do this, we're gonna shuffle all the members around like crazy. So we could, of course, do... What's the least nasty way to do this? Oh god, this is also really stupid. Okay. Boy, oh boy. We can, of course, do this, and we're good. Except for... No, we're not actually good. Doesn't help if we don't check. But this was wrong in many ways, because we're going to keep incrementing eyes. We're going to go past the one that just got moved into our slot, etc., etc. So we need this to do this as well. So there must be a nicer way to do this. I'm going to do it the stupid way. While I is less than struct. We want to go like that. Like this is cleaner. This is cleaner. And this should work. It's not. We are asserting somewhere append parent field path. In bit field helpers. Uh-oh. We messed something up. Can't remember what those are. Oh, we probably... Ugh. Yeah, I know what it is. Damn. When is this happening? Like this is in print, but when do we... But this is doing printing. Why is this affecting us now? Where are we crashing? 5690. So we go up the Bitfield pass and we're gonna probably, I assume we have missed, but not during printing. Okay, I don't know. I thought I knew what it was. I'm not quite certain, so. Okay, so we couldn't find the parent declaration for struct for Bitfield. How do we log this so that's useful? Oh, wrong. Okay, what do we want to print here? I want to log the location. Well, this is an anonymous structure. There's not much we can print if we can't find the declaration. Okay, if so we have a location, but I need to use log instead of assert, so we're going to do this. Log struct location, cannot find declaration. Okay, and we're gonna print the whole struct because that's fun, and we're gonna print the whole parent. I think the problem is, so this should not happen. It does happen, obviously, but it shouldn't happen. My mental model might be wrong when we build this extra info. I thought we do this during printing, but maybe we don't. parent. There might be one of these might cause us to generate the extra info, as it's called, for structs earlier than I thought. Probably the type alignment. I thought this happens at print time, but maybe this can happen earlier. This is all, yeah, this is in extra info. Yikes. This is struct checks. Okay, so this one, the get type alignment, might throw us off. I thought this also only happens in create extra info. Yeah. No, all of this should happen at print time, so that can't be the problem. Let's just look at it, and maybe we need a debugger. We might need a debugger for this. Unidentified parent struct. Oh, really? Yeah, because it's just parent struct. Okay, we're gonna complain. Couldn't find declaration of an instruct. So, and this is CPP library 392. So we're gonna have a look at the C code. What are we doing here? Yeah. Oh. Okay, we're doing the modification. Good. We're doing the modification at print time. No. Okay. We're doing this one gets pulled up early enough. So we do this basically and turn this into an overlay in the Jai code, obviously. This happens early enough so that the struct stuff happens later. That doesn't help us. We still we're not looking for the parent in an overlay, so that's the bug. So we do the move early enough, but no one looks in overlays to find the parent. We only look in modified declarations. We should also look in overlays. And then we say if it declaration type and it declaration type of struct is blah, decl in parent is it.declaration. And that should save us. And we can skip the loop if we have a decl in parent. Why do we keep doing this, by the way? Shouldn't we break here? And that might, maybe, save us. Parent info overlay. Yeah, this is parent struct. Actually. Boom! Works. Maybe. So, needs reordering. We have not a field 1. We have the member pulled up. Not a field 2. What are you doing here? Oh yeah, okay, that's... Now we're sad. We did so much work to not reorder everything, but since we changed these to be overlays, all overlays get printed at the end, and so they all got moved to the end anyways. Sad. Here we see that this gets turned into an overlay. That's right. The union still needs to be a struct, but just this needs to be a struct. But yeah, this works. It's a bit messy. We want a new line probably for the overlays here. Like I want a new line here, an extra new line. What happens here? Yeah, we see that the reordering has happened here. So U2 gets pulled before U1, and then U1 gets turned into an overlay, and this was the thing that made us explode before. The rest of the bit field still seems to be fine. And now we print these in the other order, because now that U2 becomes U2 gets printed before U1, also the helpers get printed in the other order. So we first have the U2 printers, and then we have the U1 helpers. We generate the U2 helpers, then we generate the U1 helpers. Makes sense. This all looks great. Wait. Danger. Stranger danger. We dropped the align. Is this a problem? Maybe. So it's gonna, the overlay means we're gonna be at the position of union A. The align itself is not necessary for this field. Because we inherit this union A's position anyways. Could this affect padding? Overlays can't affect padding, because by definition the overlays cannot grow the size of the struct. So this should be fine. Okay, so final step is missing. Final step. Okay, and now let's run this. Modules, bindings generator, tests. I have no idea. Is it main? Looks okay. What's tests? Also okay. You know what? Is this not like that? Oh, it's all uppercase. Never mind. Okay, and which one is the real one? Just out of curiosity, I think it's main. But no, it's tests. See? We almost ran the wrong one. Oof. Oh, didn't want to write. Yeah, but all okay. Good. Oh, hey, Togglebit. Raid and run. Need to sofa. Why do you need to sofa, man? How are you? I guess he ran. How was his stream? What were you guys doing? Seems like Jai has some inconsistent behavior when it comes to evaluating in loops. If the start and end, I assume you mean if the start and end of the range are variables in the scope, it seems it will reevaluate it. But expressions are one-time evaluated. There's a note in how to looping about it. Only read it once, just before the loop begins. Yeah, that's weird. I mean, it's okay if you know it, but it's a bit of a foot gun, and we like to avoid foot guns in Jai. So this is meh. But also, yeah, I see where you don't want to call this for every iteration of the loop. So, a bit torn. Valigo has an interesting taste. Yeah, I think the note I just saw this, right? Oh, it has a need to fix here. Yeah. Yeah, that's why I converted it to a while, because then it's obvious what happens. Like, you don't need to big brain the loop we wrote. Yeah, no one answered. Like, what was Togglebit up to? What are you guys doing? Or do crabs don't talk? That's not even English. Do crabs not talk? Okay, guys, we're gonna do an xjr generate all and see if we broke anything. And if we didn't break anything, we should get a bunch of new bindings. Oh, Rosetta is still trying to compile. Yeah, done. Good. And then while this is running, we're gonna do a Docker build. We have a new beta. We're at 0230 officially. Yeah, we don't need to do this. Okay. No, I don't want CI actually. I want the other one. Yep. So we're gonna build a Docker image so that I can regenerate the Linux bindings. And they're discontinuing Rosetta? Really? Man, I hope the new guy is better than Tim Apple. I really hope so. Still, no one has told me what Togglebit was up to. And why he needs to sofa, whatever that means. Support for Rosetta 2 is planned to be mostly discontinued by late 2027. Yikes. When will Jai be released to the public? When it's done. Yeah, I heard a couple of chicken butts in yesterday's stream. Okay, we'll wait for this to run and this to run, and I'll grab something more to drink. I'll be right back. Why was Jai needed? What do you mean? You can watch John's original talks if you want to see that. Okay, let's see. This looks sensible. I mean, it's quite... What I don't like about this change is it's quite messy. If you compare the old code to the new code, yeah. Also, what I just noticed for our overlays, yeah, let's do that. We don't align the members, which makes everything extra messy. So let's take our win for now. First, let's document all changes. Actually, shall we even document? No, this is actually, whatever. This is not user visible, doesn't matter. And then we have modules bindings generator. The generator will generate structs with overlay instead of plain unions in anticipation of latter being deprecated. Okay, but we're not done. Okay, we can delete my little experiment. We go in here and we do, where do we do, are we doing the overlays? Here we're doing the overlays. So we're gonna do a two-part run, like we do here. Oh no. This, of course, doesn't work. Sag. We'll have to do this by hand. Okay, question. Question to the audience. If we, where's our new one? Needs something. If you have a hot mess like this struct, and maybe assume that there's a new line. Question. Do we want all of these field, because normally if we have, where can I see this? Yeah. Fields are normally aligned, as you can see here. Or maybe those are nicer. Like the binding generator emits fields aligns. Well, I can't speak today. Emits fields aligned. Is there anything here where we can see this that's not a complete mess? Yeah, you can see it here a bit, but you can see it here a bit, but it's all like, it's very artificial tests. Let's maybe go to mod POSIX macOS or something. I'm sure we can find something nice here. For example, syscall is maybe a bad one. Let's do base. Sure, there's a nice struct. Yeah, here you can see that we emit fields aligned. Okay. And so we pad the types so that they line up nicely. What shall we do in this case? When we do the needs reordering, when we do this, shall we just do the alignment for the overlays? Something like that. It's a bit like, you have to keep in mind that it's a bit artificial here because of the super short names with one very long name. But we could do it like that. Or we could align it together with the regular names so that, like, let's assume we didn't create a complete mess for testing purposes and someone sensible wrote this code and wrote the struct something like this. Do we want this? Or do we want this? Kinda. Like, assume we have something longer here. Then basically one might look like this. That's solution A. And solution B would be align both the regular fields and the overlays together. You vote for no alignment at all. That's not an option, Valigo. You're fired. I haven't watched Valigo's presentations on Wukash podcast yet. I'm way behind on Wukash podcast. Glad to hear you like the streams. It's me, Donut. What's the meaning of an overlay? It's basically union but explicit, and you can merge it in regular struct. You can put it into regular structs. It means this member, oops, fat fingered that. The member A overlays C, so it's at the same location as C, and it's a different interpretation of the same memory, but it basically, the difference between a union and overlays, we say C is the authoritative field. So whenever we need to interpret the memory of the struct, we're going to look at C. We're not going to look at A and B. That's important for, let's say you return, like some of these are pointers maybe, and you return them from a compile time metaprogram. We need to know whether we need to interpret, like if this is a pointer to U8, for example, we need to know whether we should treat this as a U64 and marshal it across the, like from compile time to runtime as a number, or whether it's a pointer and we should marshal it as a pointer, which means we're gonna, like, this is maybe pointing to global data and it's a pointer that should be preserved or whatever. So overlay makes it explicit which parts of a field are the authority when it comes to converting these structs between, let's say you save them to a file or you whatever. So this kind of thing. If you do alignment, I would vote to align per block. That's actually a good idea, except, like, I like the per block idea, except the Jai code might have different blocks than the C++ code for libclang reasons, partially. So we might get weird alignment, but maybe it doesn't matter. Maybe it's about, hey, do we align this in... Yeah, actually, I like the idea of doing it per block. It's harder, but I like the idea. But it like implicitly it would mean overlays get aligned separately, even if we don't do the full block alignment yet. Like right now, the way it's written right now, these two would align even if there's some garbage in between. Like this and this currently align even though they're separated quite a bit, which looks a bit weird. I agree. So maybe it should be like that. But we should separate the overlays with a new line and then just align the overlays, maybe. Yeah. If we're forced to have some alignment, yes, you're forced to have some alignment. You would align overlays separately. Okay. Simpler way to make tagged unions? No, it's not about tagged unions. This is... Yeah, math is a good idea. If we go to matrix, maybe. Here you could see a good variant. You say, hey, I have these members. It's 4 flow. Well, 2x2 matrix is weird. We have a 4x4 matrix, and over the first element, we overlay... Wait, how does that work? Oh, never mind. The overlay can be bigger than the member, it just can't be bigger than the struct. Okay. So we overlay a 4x3 matrix on top of the 4x4 matrix, and we overlay an array of vectors, and we overlay a different interpretation as coefficients instead of individual, like named members, and we overlay an array of floats. So basically, these are all different views, but these are the authoritative members. So if we print that struct, for printing, it's also important for printing. If we print that struct, we're going to print the members, not these different versions. That's the idea. Okay, anyways. The not so benevolent dictator, have decided that we do the alignment separately. Now I just have to think whether I do a crazy metaprogramming trick. Yeah. I think I'll regret this. This is declarations is an array of something, and then we have a get name function that's maps t to int get name size maybe. And then length is get name size it. Nope. These need to move. None of this works. Okay, I have to do this. I'm sad. Not sure if that's worth it. Bam, 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 bam. And then we can do something fancy like max overlay length is get name alignment struct overlays, and we'll say a is a dot declaration. Does that work? I rarely use lambdas. And then over here we'll have to say blah blah blah. Where's the max lame align declarations? This will not work. And it works. And we should have some white space changes. Yes, it's pretty much as I wrote it. Great success. Except, of course, not. Oh! Okay. This needs fixing. Is it our place or our placement? I can't remember. Place. This will... Yeah, this will not parse. Even if I wrap it like this. Can a lambda return more than one return value? Like a quick lambda like this? I don't think so. Sad. Okay, we'll do the messy thing. Declaration overlay. Why is this plural? Which moron wrote this? There's an overlay, not an overlays. Guys, someone stupid wrote this. And this returns a declaration and an int. And it looks like this. Return a declaration, a blah, blah, blah. Luckily, this is easy to transform in Jai. Okay, get name alignment. And you want get declaration, which is and this is a type, blah. How does this, I guess, do I have to put this in? I've never done something like this weird in Jai, or not in a long time. This is declan extra lang. Safety squint, yeah, none of this works. Unical identify get declaration because I renamed it. And extra length. Sometimes I'm surprised how easy it is in Jai. Yeah, this is stupid. This is stupid because now I added too much padding. Never mind. Because that's wrong. I just wanted to... What I wanted to do. I thought I was smart, but it was not. I wanted to say, oh, we just add this, the length of the overlay name. We're just going to add that to the name. And where was the thing that was not nicely aligned? Like if we, let me find that case again. If we do this, the base thing and just return 0 here. So actually for overlays, we need 2 alignments. That's the thing. Let me just find the case first. Where was it ugly? So this is all fine. This makes sense that these are aligned. In the end, here it's weird because it aligns this to this, but it's still misaligned. So that's why we add 2, because this is 2 bigger than that. But it's still misaligned because this is also 2 bigger than that. So it's still misaligned by 2. So we would have to align the asses in this case. So we need to do an alignment for this and then an alignment for the rest if we want this aligned. And my quick naughty hack here did not help. Who was it? Oh yeah, it was. I'm currently watching the back catalog of Casey's Computer Enhanced course. I've been subscribed since day one, literally. Like as soon as the newsletter dropped, I subscribed to Computer Enhanced. But I haven't had any time to watch it actually. So I've been paying for years and not actually. I watched the first part and then I just stopped. But kept paying because it was like, yeah, Casey's doing awesome stuff. Like, why not give Casey some money for the awesome stuff he does? But a while ago I started to, no, actually I should, like, I have to catch up. So I started like speed running the whole Computer Enhanced course, the Performance Aware Programming course. And the one I watched yesterday, I think, was where he described Clang as a naughty compiler that you have to watch because it's usually like it does good things, but from time to time it completely screws up the generated code. Like not from a correctness standpoint, but from a performance standpoint. So he described Clang as a naughty compiler, which I loved. Okay. How do I build Jai on macOS? With the Jai compiler. Okay. So we needed 2 paths for overlays. We're gonna undo this nonsense. No, we don't. Not gonna undo because there was something nice in here, which was the renaming of declaration overlay. So this one will stay as declaration. Maybe we need to do something custom here anyways. Here we do the overlay. So we're gonna do get name alignment, struct overlays. Oh, ooh, we can use the same thing. We want a place, and now we can actually use the Lambda form again. So we're gonna say d is d.place. Sometimes these are nice. And this is d.declaration. And so we get both lengths. And how do we do the what was it called? Align declarations. Or we just do this by hand. Awesome. Okay, we can do this by hand. We're gonna append builder overlay. No, we're gonna do the whole thing actually. We're gonna do this. And then we're gonna say for it plays output name count till max overlay place length -1. We're gonna add blah. I think we need to go till length here, but we'll see. And then we do this as we did before with the max overlay length. Okay. And that should be good if I was able to actually undo my damage to the get name alignment, which I did not do. So we'll do this, now it should be fine again. Nope, not quite. Delete all the craft that I added. Okay. All in the name of alignment. And you don't value my work, Maligo. I'm so disappointed. And this is only slightly wrong now, which is great. Why do we add padding here? Why? Place output name count, max overlay place length. So this should be, for a single member, this should be 0, but it's clearly not 0 because we keep adding a bunch of crap. But as you can see now, these are nicely aligned. I mean, there's too much crap here because I get some numbers wrong, which surprises me. Oh yeah, never mind, because I forget that we add some raw. Why do we add some raw? But it's output name. That's the one we're using. What am I doing wrong? I'm sad. Oh, and of course this becomes aha. Magic. And we can even bake this if we want, if we're afraid that this is slow or something. Doesn't matter. Really doesn't matter. Hey Natsu. You need you want to pay Casey badly, but I need some trick way to send money to USA. You can do what the USA currently does to pay us, which is send us checks. No, I mean, I know that wouldn't work either, but I find it funny that, did I tell you that story? I'm not sure. So for Fabman, for my company, quite a few of our customers are American universities. And from time to time, like most of them pay annually. No, some of them pay annually. And like normally you can either pay by credit card or by like bank transfer if you're in the EU. But some of the American universities, when their annual invoice is due, we just receive a letter in the mail with a check of, I don't know, $8,000 or something. And it's so weird. It's a normal letter. It's not any special, like, I don't know, like priority, whatever you call the English version of like, no, we guarantee that this gets delivered to the right person. No, it's a regular letter and you open it and there's an $8,000 check in there. And then you have to take that weird piece of paper to a bank and the clerk looks at you confused because they rarely see anything like that, and then they have to ask how to cash in that check, and then you pay a huge fine, etc. $8,000. I'm rich? No, $8,000 per year for like it's. I'm quite sure they're laughing about how cheap we are. Embassy here do the same with your government idea. Yeah, it's crazy. But like with the government ID, okay, I don't know if someone like if that letter gets misdelivered or drops on the floor or something, like there's just a check in there for, I'm not sure. I guess I've never like I don't handle the checks. It's one of my colleagues, but he showed me one once. I assume the recipient is on the check, right? So you need your ID to cash in the check, or can anyone who has that paper now get that $8,000? Like how? It's, I don't know. It's weird that they still use that in the 21st century. Okay, let's figure out where this extra length comes from. We use the place to determine the overlay length. And I assume this would include the, like it looks, like why do we have 1, 2, 3, 4, how many? I can't select. 2, 3, we have 4 extra padding in here. As if we assumed that here it's 6 extra padding. If I count correctly. 1, 2, 3, 4, 5, 6. Yeah, my eyes are not off. Why do we think that we need 6 here? It's the only overlay. So whatever this returns should be the same as the length here. It's weird, isn't it? Oh. Huh. It's this one. Ah, damn it. Our generic solution throws a wrench into our system. Because yes, this declaration has a using on it, but no, we don't print that here, so you shouldn't have added it. We can make this more, like, at some point this becomes stupid, but we're gonna do it anyways. now we're in naughty land. Don't do this, kids. Do as I say, not as I do. This is better. It's still wrong. No, now it's right. Now it's right. Oh, this code is gonna be so pretty. Look at it. It's actually not pretty. Like this inline struct makes everything worse. But pretend it looks like this, isn't this? Yeah, this is an artificial example. It's gonna be really pretty in reality. Trust me. Trust me, bro. Just one more alignment. It's gonna be great. Do we have anything with more overlays where we can actually show the real beauty of this? Nah. Okay, let's let this loose on the real, on all the bindings, and we'll see. Hey, Lars. Oh yeah, we want to add the new line before the overlay, by the way. We're gonna add a new line. Yeah, look, this looks nice. Doesn't this look nice? I think this looks nice. So in this case, yeah, J value has a J long in it. The J long gets pulled forward. Looks reasonable, I think. This looks right. POSIX, that's gonna be a mess. So Sigchild gets moved to the top. Seems right. Then we have all of these and they get aligned. And then in this in the Sigfold struct, we haven't in the Sig, what is it? In the SI field struct, we have Sigfold, which is another struct that contains a union. So that's gonna be tasty code. But look how nicely aligned it is. Okay, this, I want to change this to not say anon union. So we're going to say we're going to do this and say if x struct dot name else nothing. That doesn't work. We have to do we really? Yeah, I don't want to duplicate that code. We're gonna just make that mess. Don't judge me. This is stupid. Well, yeah. No, you know what? No, we're gonna do this. We're gonna be nicer. We're not gonna make that mess. We're just gonna say if f struct name else struct. How's that? But this all looks reasonable. And it looks like we did nothing. Oh yeah, this one did not happen actually. Why? Why? Why, Mako? Why do you have a union with one field? What's wrong with you? What's wrong with you, Mako? Why? Okay, guys, why would you do that? Like, what's the reason? There must be a reason why you do that. No one just tosses in a union for fun. Like, what are we losing by doing that conversion? Is this some C stuff I don't know? What's the benefit of using a union with a single member? I guess different initialization rules apply, but doesn't get... Yeah, I don't know. Like, any C masters in chat? Why would you declare a struct field as a union with a single field? It could be that you want, so you maybe you this is forward thinking of like maybe we want something else later in here, a different interpretation or something, but there's none. So why are you like that? Yeah, but like if you haven't done it by now, it seems like it was a mistake, right? Okay. The only thing that's a bit sad is that we do the overlays at the end of the struct instead of where the original member was. But yeah, that's the way it is. Okay, we're gonna regenerate. Oh, and I have to stop pretty soon. So this might be all we get to do today. Let me rebuild this one as well. Of course, it's legal. The question is why, or like, what benefit are you getting by just using unions instead of structs? What does Steam look like? This looks fine. Oh, and something I just realized. We're probably not generating struct field checks for overlay thingies. Maybe we should do that. Maybe we should do that. Okay, what has changed? Yeah, now we just say for struct instead of n on union one. That's clearly better. We have the new line in the overlay before the overlays. Yep, I think we'll take that win. Okay, so this smells like success to me. What did we change now? Just the alignment, right? Yeah. Okay, this one is done as well. So we're gonna do docker run blah 30. I don't think we need the entry point. Instead, we're gonna say opt jai generate all jai boom. This is gonna take a while. While we're doing that, we're gonna push this and do the Windows version. Windows looks clean. So let's pull this over. Okay. Good. Let's build a release version of the compiler because generating the bindings on Windows is slow enough as it is. Oh no. Oh no, we found something that's not working. Where was it? We're in socket generated Linux. We do some, yeah, ugh. Why are you like that? Oh, damn it. Life could have been so nice. But some Linux programmer had to be nifty. Okay, so they have two different, so they have a union. There's a TCP header. They have a union. It contains two structs are both anonymous with like these are two different sets of fields. They're not namespaced as in like they're both in TCP headers. You can say TCP header th_sport to get the sport, obviously like football or rugby and then you can also say TCP header source and reinterpret the sport as a source, which is great. It makes me sad. What do we do in this case? We would have to print this one as using anon struct 2 so that we can overlay this one. And then the overlay needs to be a non-anon struct 2. So not a fan. Not a fan. Hey, Solfoam. The problem is we're turning unions into, like, we're turning plain untagged unions into structs with overlays so that they have well-defined semantics in Jai. But someone in the Linux TCP headers was nifty and packed a union with anonymous. He packed an anonymous union with several anonymous structs, which I find yucky, but I understand. Yeah, okay. Guess that's what they're doing. And so our generator just generates the wrong code because we're trying to overlay on anon struct. Anon struct doesn't exist, and then this one doesn't have a declaration either, which we don't support. I'm sorry. So we have to massage this code a bit. Let's see if Windows turns up more trouble. Jar generate all. Okay, while this is running, we'll think about the sins we have committed. So when we put things into overlays, over here, we would have to massage the declaration. The qualify using is on the declaration. Okay, so we're gonna say it flags or equals qualifier using, no, if not it dot name. How do we this is not a declaration, this is going to be a struct. Let me look at is struct field. Yeah, if it's a struct and it's an anon field, boom. And we get the anon struct. Okay. So we would have to turn this into a declaration. That's number one. This will not save us completely, but it's the first step. Okay, so if we'll do this differently. Do this. If is field blah. Let me see. If anon struct we do the following. We create a new declaration. We have this, I think, which takes anon struct output name. The type is, we have to create the type, is create struct type, no. How do we do this? Type of struct. Oh, we just say new type, whatever. Decal type of struct is anon struct. So we turn this anonymous struct declaration into a proper declaration. That's what we're doing. No, I don't mind anonymous structs and unions. What I what I don't like here is we have an anonymous, like union, whether anonymous or not, but we have a union that contains two anonymous structs. So you have the fields just, you have a field soup in the union, basically, of all the nested structs. I don't like that one. So we create the declaration, we say decal type size is anon struct. Wait, this is actually easier. The struct has a type. The type is of type of struct. We don't need to do any of this. We say create declaration. We say anon struct type. Let's make it easy. Now we need something else, right? A name, a type, and a cursor. We don't have a cursor. So we're just gonna take this one. And we do anon struct location, and the comment should replicate. We'll see. So we create a declaration. Boom. The decal gets flags of qualifier using. I have to go in 5 minutes. We have to hurry. And then we say it is decal. And that should give us the right declaration. And then we don't remove. Oh no, we still remove. Okay, let's try that. The problem is, okay, let's replicate this because I don't want to run the whole yucky Linux container every time. So we're gonna have this nasty piece of code here. Union multiple anonymous structs. So we're gonna have struct uint8 ta, and we're gonna have struct uint32tb. No, let's not do a reordering because it just makes a mess. Let's do that. That's what you want, right? Blah. What? Flags isn't a member. Outrageous. I'm in a funny mood today. Okay, this looks good, maybe. So we get multiple anonymous structs, and now this is using an unstruct4 struct. Perfect! Except, of course, this one also needs to be converted. So that's the same thing once again. I'm gonna do this. We have first field index. If first 3 minutes to go. Struct declarations, first field index is this. We're gonna say if we cannot place overlays on an anonymous struct, so we have to turn it into a normal declaration plus using. Same here, we cannot use overlay on anonymous struct, so we turn it declaration plus using. Okay. And we only need to do this actually if we have more than one field. If someone's just stupid and does this, there's so many test cases. Single anonymous struct. Like in this case, we don't need to mess with it. If someone wants this stupid code, they can have it. They can keep it. So we only want to do this if we have more than one field. So we're going to do blah. Blah, blah, blah. And we're going to change this to first field. Immediately. And we're going to say struct declarations for field index is first field. Voila! And I hope no one references this because we just replaced it. Okay. And here we're just gonna say it is blah and it is blah and be happy with it. All right. That should compile. Yes, we're currently still converting the single one. Yeah, now the single anonymous struct also gets that treatment, which is a bit sad, but, well, tough luck. And it gets the underscore treatment for some reason. That's a bit weird. But anyways, this now works. Hooray. This looks sus. Why do we suddenly have a line 4 here? Something's off. Oh, because we didn't... Yeah. First field. There's something we need to copy. Bit offset in parent. Parent is anon struct bit. There might be more, but definitely this one. Same here. That might get rid of that. We're just gonna do boom, boom, boom. Rerun this so we see the diff more clearly. No change. That's not good. This is hum. I did not expect that. Yeah, I'll have to debug this. There's something fishy going on. We do some computation, alignment computations wrong now that we replaced the declaration. It must be because we're not copying something from the struct to the declaration. We'll figure it out. But I have to go. So we'll stop here and just, I'll do the rest offline probably. Let's see, anything interesting? The goal is to get you most of the way there. Almost everything should work out of the box. If you unleash the bindings generator on some STL infested code base, you're on your own, basically. All right. Yeah, it can turn enum-like defines into proper enums. There's a flag for that. It does it by default, but you can opt out, of course. I think it does it by default. Not quite sure. Anyways, okay, I have to run. Thanks everyone for stopping by. See you soon. Bye.